Okay, so question number 9 has a picture of the graph that looks like this. It is the axes here, and I know I'm just going to make a brutal picture of it just to make things go quicker, but roughly it goes like this, and it hits the axes here at 2, and it makes a low at -4, -4, and it goes as high as +4. And the other side is 6. And that's up at 4. So it says here in this question, this is the graph for f double prime. And it tells me that the first derivative at 1 equals 0. And then it says, let's find another spot where x equals 0. So what's the other place that could have happened? So here's what we have to think about. Okay, what does f prime tell us about in relation to f prime? So going from double prime to prime, how are they connected? Like f double prime is blank of the derivative, which tells me about slope and one other thing. Remember, I said there were 2 important things you always had to think about for a derivative. Rate of change, okay? So if we take an integral, we add up all the changes, that'll tell us the total amount of change. Okay, so we have one clue in this problem. It tells us that if I'm up here on the graph, at 1, on my original f prime, I'm at a 0. So what I have to do is figure out, okay, if I start here, I need to figure out how to make the total change equal 0, meaning no matter where it moved, it undoes itself. So for example, if I look at the area here, that's positive, so there's going to be, add up all those little changes, it's going to be a positive number. I have to sort of counterbalance that by taking out another one here. So I have to take away just as much of the triangle in order to have the same amount of area. That way, if I call this number 1 and I call this number 2, if you add those 2 together, the net result is nothing has changed. However much this has increased from here to there, that means it's going to decrease by an equal amount as I move to there. This value is at 3, so x equals to 3 should also be a spot where we find it equal to 0. Okay, so for number 12, we're doing the total area bounded by the region of y equals x root, sorry, I've lost my place here, 1 minus x squared. And it also says the x-axis. Okay, so between this curve and the x-axis, we have to try to figure out what the region would be. So when we find the area between the curve and the x-axis, that's just a normal integral, right? You know, draw any function you want, right? Like, whatever it does, the area underneath the curve, between the curve and the x-axis, that is the integral. So basically what they're asking for us to do is figure out the area if we integrate this piece here. This is number 12. Okay. Now it says the region bounded, so at the x-axis, what I'm looking for is I want this to be equal to 0. So if I try to figure out where that's going to happen, there's a couple places I can see right away. Here, when x equals to 0, and here, when x equals plus or minus 1.
Why you want it to be 0?
Well, that's one possibility of where it's going to be equal to, it's bounded between this line here and the curve. So the curve, that line is y equals 0. That's why I want it I'm looking for where it touches the x-axis, the x-intercepts. Okay, so the pieces that I'm looking for, I can see that I'm going to have a couple of pieces here. Okay? Now, if I'm looking for the total area bounded between it, what I should do is, if I think about what this graph is going to look like, these numbers that come out of the square root are always positive. These numbers that come out of x are going to be positives and negatives, depending on what x is. So this is the only value that changes the graph. So what I know is that on this side, the graph is going to be below the x-axis. So the graph's going to be somewhere here, and then somewhere above the x-axis when x is positive. Okay, x is negative, it's the left side of the axis. This graph will also be negative. Okay, when x is positive, this graph will also be positive. Okay. Now, one problem, of course, is x can't get beyond 1, otherwise it wouldn't be defined there. But we're not going to integrate there, so it won't affect this problem. So I think we should be able to get this integral by going the integral from -1 to 0 of, this time, like I said, the area is underneath the curve. So if I want to know how much area there is there, it's going to be the negative, because it's below the x-axis, of x root 1 minus x squared. And to that, I'm going to add the area from 0 to 1 of the curve, and it's above the x-axis, so I don't need to change the sign. Okay, so the nice thing is you can see that these, when I integrate one of them, it's going to integrate both because they're the same function. So when I spend the time on one, I'll actually end up being able to do both. So let's try that here. Let u equal 1 minus x squared. Du is -2x dx. So to do this integral, I would have to put a -2 here. So I'll have to put a -1/2 in the front. So that means I'm going to end up with -1/2, the integral. And for this piece here, it's just going to be root u du, and my bounds need to change. So if I put in 0, that means it's going to be 1, and when I stick in 1, it's going to be 0. Now it's not necessary, but if you don't like the way the bounds are, you can change them by adding a negative sign. So this becomes positive root u du. So that means it's going to be u to the 3/2. If I divide by 3/2, and I have to multiply by this half that's in front. So this is going to be the same thing as if I brought the 2 up. It'll be u to the 3/2 over 3 from 0 to 1. Okay. That, at 0, nothing happens, but I get 1/3 minus 0. So I get 1/3 for this area. And now I need to do it again for the top one up here. Now, what we can do really quickly is when we see this from -1, the bounds, like we're trying to save time, so let's reuse what we have. If I put the bound in here for -1, that means I'm going to be at 1 minus +1, so it's going to be at 0. If I put in the bound of 0, that's going to be 1 minus 0, it's going to be a 1. So it's the same integral. This time, though, it's going to be, the bounds on it are going to be from, what did I say here? 0 to 1. And it's going to be the same thing, root u du. So that ends up being the same piece I already had. So there's going to be some symmetry here. It should be the same area. So I should end up with 1/3 as well. So I think we should end up with 2/3 as the total. Is that even...
Yeah, that's the answer.
Yes! Okay, so they don't... 2/3 it says is D is the answer there. Okay, so